Okay, so we're going to start talking about something called imaginary numbers. And we sort of started to touch on this in our previous units on radicals. If you remember, it's possible to have a negative cube root, something like this, because I can actually get a real answer. In other words, if I say -2 to the third power, that's -2 times -2 times -2, which gives me -8. So the answer to this is -2. There is an answer, a real numbers answer that gives me the cube root of -8. However, if I do square roots and I say the square root of -25, okay, now if you try that, we know that the square root of 25 is 5. But if I try to do -5, and we say -5 squared, you know that -5 times -5 is positive 25. So there's no way that I can get a negative number here. So this does not have a real number solution. So this creates some problems. And so, for example, if I have this equation here, x squared plus 1, and I wanted to solve this, okay, this is actually a quadratic function, okay, that is a parabola, forms a parabola when you graph it. So I should have some solutions when I solve this, but if I move the 1 to the other side, I get x squared equals -1. Then to get rid of the squared, I would take the square root. And so then I get x equals the square root of -1. And there's no answer. If you try to type that into your calculator, you will not get an answer. So what do I do then? So a while back, because of this, mathematicians defined this unit called an imaginary number to represent their solution, so they could start to come up with solutions on this that made more sense. And they used kind of a script I to represent imaginary numbers. An imaginary number is defined as the square root of -1. I is equal to the square root of -1. So this is useful when working with square roots of negative numbers. A pure imaginary number is written in the form bi, where the b is just like a regular constant, and the I part is the imaginary number part. So for example, if you work and you get a final answer, it's possible to have your final answer be 7i, for example. A regular number and then an imaginary part after that. So 7i is a possible answer. So that's when we talk about one bi. Okay? Now, what you're going to do is you're going to break these apart just like you would any other square root, except now you're going to contend with this I imaginary part. And you want to take out that -1 part first, and because that will be an I, and then break apart the a value as you go through this. You'll see what I mean here. Make sure you're always simplifying as much as you can. But for example, if I take this, I'm going to break this apart into these two things. Well, now I know the square root of -1 is I. I also know that the square root of 9 is 3. Okay? And then when we write these, just like if we were writing 7x, we always write the constant in front of the variable. So this would be written as 3i. Now, when we do square roots, we would normally say plus or minus. If it's an equation, you want to use plus or minus. But if it's an expression like this one, you can just use the positive version. Okay. So let's take a look at another one like number 4. Okay, so once again, I'm going to break this apart, -1, and then square root of 80. Now, the square root of 80 is not nice, so you're going to have to break this apart. You know that this is going to be I. This you want to break up into the perfect square part and the not perfect square, right? So let's see. The biggest perfect square that goes into 80 would be 16 times 5. Okay, so now you know this is 4, this is I, and this is root 5. Okay, now if you have a radical left over, what you're going to do is, I want to write your answer, you should put the bi part in front of the radical, and again the constant in front of the I as well. So this would be rewritten as 4I root 5. Okay. So now we're going to do our notes a little bit different. We're going to do our notes here, and then I'm going to have you finish these other ones. So 2, 3, 5, and 6 you're going to do on your own. I'm going to continue moving on through a couple of these other ones to get you used to this. Okay, solving equations. Just a quick reminder that when we solve an equation and I get a square root of 25, okay, x equals the square root of 25, this has more than one answer. It's 5 and negative 5. Okay, so keep that in mind. When we're solving equations, we want to write both answers now. So there should be 2 answers when we do these. Okay, to solve, I need to isolate your x squared and then take the square root. So in order to do that, I would start by subtracting 81 from both sides. We get x squared equals negative 81. And then take the square root of both sides. Square root will cancel the squared, so this will give me x. And this would be plus or minus. Now, I want to break that apart. You can break this apart as that, right? And this is I, and this is 9. So this is going to be plus or minus 9I. And this would be my answer. That's how those work out. A little bit trickier one here. Again, when you do these, you always want to isolate the x squared and then take the square root. So once again here, I would subtract 15 from both sides of the equation, get 4x squared equals negative 24. Divide by 4, I get negative 6. Take the square root. I'm going to write plus or minus right away so I don't forget. Now this is going to be negative 1 and 6. Now I can't break apart 6 anymore, so this is just going to be I root 6. So there we go. I want you to try these other 8 and 9 on your own, and 11 and 12. Okay, powers of I. So let's talk about how we can recognize how this works a little bit. So we already know, let's do a different color than that. We already know that I to the first power is the square root of negative 1, and that this is equal to I. So great. I squared, square root of negative 1 squared. Well, we know what square roots and squares cancel each other out. So this just ends up giving me, crazy as it may be, a real number, negative 1, no I in there. Okay, kind of weird. Well, this is I squared times I, right? And we know that I squared is negative 1. So this would just be negative I. This would be I squared times I squared. We know that that's negative 1 times negative 1, which would be positive 1. And this pattern, you can kind of use this to just keep kind of going here. You'll notice this would be I to the third times I squared, which would be I to the third is negative I. And I squared is negative 1. So this would just be positive I. You'll notice it's the same as I to the first power. And this pattern just kind of keeps continuing. So there's a variety of ways I guess you could do this, but you might say this is I to the fourth times I squared. I to the fourth is 1. I squared is negative 1. So this is negative 1. And you'll notice you get the same thing. And you can continue this pattern. You'll notice it stays the same here throughout. So you can get to I to the 15th by kind of using these things or patterns or however you want to get there. One way you could do this maybe is like I to the 8th times I to the 7th. And you would say, oh, that's, let's see, 1 times negative I. So this would be equal to negative I. Okay. Yeah. See if you can figure out I to the 62nd power. Okay. I want to go through a couple of these just to make sure that this makes sense. So here, if you multiply this, you would multiply the coefficients, so you'd get 28, and then I times I is I squared. Now you're going to look back up here and you say, oh, I squared is negative 1. So this is really just 28 times negative 1. And as weird as that might be, this is negative 28. Okay. All right. And those other ones, kind of use your power property or exponent properties to see if you can figure it out. I want to jump down to the bottom one because it's kind of confusing. When you have these negatives in here, you want to take the i's out first. So I'm going to actually write that. And that will apply with number 20 as well. So kind of keep this in mind. So really what I want to look at is I'm going to take out that negative. So I would do negative 1, take that out, and this would end up being this, right? Same thing here, and I'd have that. And now I can multiply the I times the I, give I squared. I can do 18 times 10 and get 180. Okay, I know, let's do square root of 180 over here. This would be, the biggest perfect square that goes in there is 36. So this would be 6 root 5. Okay, I squared is negative 1, and this is 6 root 5. So this would give me negative 6 root 5. Okay. What I'd like you to do then is go through and do the rest of these problems. Hopefully this helps. It's a little bit different way of going about it.